Hi, I'm Steve Horton, Volvo Trucks Research and Development. Welcome to Greensboro, North Carolina. This is the VNRE. This is a fully electric Class 8 truck that's capable of moving 80,000 pounds with zero tailpipe emissions. And this is one of 8 trucks that Volvo Group has globally, which is zero emissions. This truck was launched in 2020, but the truck that you see here today is a new enhanced model. With better battery technology and more capacity on board with this 6th configuration, we now have 565 kilowatt hours of power on board. You know, this industry is changing quickly, and we are determined to stay on top. But to do that, we need to be agile and we need to be effective. That's why the truck I actually want to talk to you about today is the one that's parked in this bay. And to see that, you're going to have to wear one of these. All right, so what you see here is a digital version of the VNRE. And in addition to looking really good, what's impressive is that this is actually a full 1-to-1 scale model. And it contains all 12,000 of the parts we would have on a real physical truck. The other thing is, with this being virtual, there are some things that are possible that we couldn't do with a real truck. And the first is I can introduce my co-presenter here for today, Jan Worster. He's in Stuttgart, but we're here today looking at the same virtual truck. Hey Jan, first of all, I really want to thank you and ESI for the great collaboration that we've had, throughout this project and this development, so thank you.
Hi Steve. Indeed, it has been such a great experience to build this together, and on behalf of both ESI Group and NVIDIA, let me also thank you for the opportunity to share this with the GTC community. I'm sure we both agree it would have been great to do this as a live GTC, but on the other hand, not sure how you would have been able to bring this serious piece of equipment into the talk.
Yeah, thank you. And I'm really happy that we can be here today to show this together. So, I don't know, what do you think of the truck?
Well, I have to say, it does look awesome. And with being a fully electric drivetrain, I believe this also represents how Volvo is working to, even today, bring us to a more sustainable future.
What do you think? Do you want to take a closer look under the hood?
So, what is under here if we don't have a diesel engine?
Diesel engine powers a lot of different systems on the truck. So without it, we have a modular power box, and then we have to electrify some of the components, such as the air conditioning and power steering. And we also need the cooling system on the truck. That helps regulate the temperatures in critical components like the batteries.
So where does that leave the electric motors then?
All right, so this is where I think the digital truck is just amazing. Jan, why don't you change the visualization here so that we can just see and take a better look at the electric drive line and the batteries. If you look down in the middle of the truck there, you can see there's 2 electric motors, and those are connected to our I-shift transmission. And from there back, it's like a standard diesel powertrain. So with a prop shaft that goes back to the rear axles and the suspension.
So I have to say, I did glance at the specs for this a little. And is it true that you managed to pull off more than double on the torque that you would get from a traditional internal combustion engine?
Yeah, that's right. And what's really impressive too is that you get that torque instantly with an electric motor. Now you can take a better look at these 6 batteries. This is the new configuration that's being launched now. So, before we had 2 batteries on each rail, and now we have 2 additional batteries that are up behind the cab.
So that's what it looks like to store that insane amount of energy. What kind of range do you get under a typical load?
Yeah, that's right. So this truck has 565 kilowatt hours. And with that much energy stored on board, our customers can get up to 275 miles.
Well, that looks seriously impressive, and it's great to be able to experience it like this. I can see why this could be useful, but how are you actually using virtual reality to develop products like this on a day-to-day basis?
All right, so yeah, that's a great question. I hope you start to get a feel for what you could start to see on a truck that you can do virtually, and why this could be really useful for us in the product development process. So what I'm going to talk about today in the talk is to really go through with you, how do we use this in product development, and why is this so important, and what's the journey that we've been on, to get to this point.
And then I'll explain how we have made this technology work and some of the challenges that we've overcome on the way.
Just to let you know, we will be available to answer questions live throughout this talk. So let us know what questions you have. To understand why this technology is so useful to us, it's useful to understand the type of products we build and the type of applications that our customers use those products for. These are hard-working machines. They work in a lot of different applications, from delivering goods in what we call long-haul applications over long distances. They collect garbage, or they could deliver materials to a building site. Each of these applications demands different things of the vehicles, and to optimize the way that they work, requires different specifications. So some may need more power, some need to travel over a long distance and may need more fuel on board. They may need different suspensions and different types of ruggedness built into the vehicles. As an example, let's go back into VR. So if we take a look at the platform, or the VN platform that we built the VNRE on, that same truck platform has 4 other different engines that we can install into it, including a CNG engine and 3 other size diesel engines. We also have a number of different cab sizes that we offer, from a small day cab to a very large sleeper, where the driver can spend multiple days on the road, can sleep in the vehicle and work from that vehicle. We have a number of different suspensions, again based on what the application of that truck may be. We have a lot of different size fuel tanks to help the packaging on the vehicle and to put on the optimum amount of fuel that the customer will need for that application. We even have a number of different front bumper options, different materials and different light configurations. So what you see here is 4 or 5 options, but these are just 4 or 5 options out of maybe 700 that make up the full specification of the truck. So we have a lot of variation and a lot of different combinations that we need to build into our product. We don't just develop a single product or a single truck. We need to develop a multitude of different options on those vehicles. So this is one of the biggest challenges I think that we have when we're developing new products. One of the biggest benefits we have in the company is the expertise and knowledge that we have. I remember when I first started working in this company, I worked in the manufacturing group, and there were guys there that worked in the manufacturing engineering group that had been in the plant for 20, 30 years. They'd seen all these different options being built. They were really familiar with some of the different customer specifications and the feedback that they had on those, things that had worked really well and maybe things that had issues that we needed to develop. So there's people throughout the company like that, right? Also in engineering or in the service group and purchasing and in sales, that have a vast amount of knowledge about these configurations and these products. So when we develop the new products, we really want to use that knowledge that we have internally and build those into the next generation of products. So one of the key things that we do in a product development, a very key stage, is when we build physical prototypes. These trucks are then used for a number of different tests to make sure that we're meeting the quality levels that we expect, the durability levels that we're very proud of. When we go through those physical builds, we also learn a lot about the product. And for many people, they've seen the product before. They've been, different presentations and things, so they understand what's coming. But for many people, this is the first time that they experience the product. It's the first time that they can put their own eyes on it, that they can explore the product. And many times, we learn a lot from people. That's the point at which we maybe get different feedback on changes that we can make. But it's also very late in the development process. It's possible to make changes, but those are more costly, and depending on the size of the change, maybe it could delay the timing of when we introduce a product. So one of the things we've looked at very closely is how do we utilize the virtual data that we have, that we use to design the product and order the parts. How do we use that data earlier on to collect this kind of knowledge? So this is a picture from one of the projects that I've worked on in the past. And one of the methods that we've had traditionally is we will bring a group of these experts from different areas together into a room, and we will do a virtual run through on the truck. You'll have one person that's controlling the CAD model, and you display the picture of what you're looking at onto the screen, and everybody's looking at that and following along. We step through the process, we step through the parts, and we collect that feedback. This is a very effective method, right? We find a lot of good feedback, and again, this is the point at which people really start to understand maybe some of the details in the design. One of these reviews that we had, there was a specific issue that I remember us finding, and it was quite a big issue, and we found it maybe, say, 20, 30 minutes into the review, and it was great that we found it, right? We were able to solve that issue and resolve it before we got into the actual physical build that would come later. But one of the things that struck me was, for the number of people that we had in the review, it took quite a long time, half an hour, to actually identify that issue. And maybe the bigger thing for me was the person that identified it. The person that found that issue was the person that was operating the CAD. And this kind of spoke to me because it speaks to kind of a truth about this type of method, where it's a very effective method for communicating what you want to show people, but it's not a great method for the rest of the group to explore that vehicle for themselves and understand things or find things out about the truck. So we wanted to take that kind of a step further. Was there a way that we could kind of empower more people to be able to actually, explore for themselves? So what we said then was, okay, let's try using a different technology. Let's look at virtual reality. We have a number of people in the company that are experts in virtual reality and have used it for a number of years. And we talked to them, and again, there's a lot of success that they've had in identifying things. There's some very advanced tools and things that we can do with VR, where you can, for example, take things apart, you can practice service methods and assembly methods. So we said, well, what if we use it for this application? What if we were to take, a group of people into VR and have them explore using this? We tried that, and there were some good positive things, and then there were some challenges we had. And to talk about some of the challenges, the first is, if you look traditionally, typically we had a wired headset, and there was a fairly small size space that we could use that headset in. We have a big product. This product didn't fit into the size space that we could move around, and that leads to a problem. It's okay if you're looking at some components, but if you want to look at the total truck, and again, you want to give people this ability to explore and move themselves, you can't
navigate around. Now, the experts said it's not a problem, right? You use one of the hand controllers and you use that to navigate and move the truck. And then you can see what you want to look at. What we found in reality was some people were very good at that, but some people, this was very new for them. And so when we gave people this ability, what they would do is typically they would spend a lot of time just trying to figure out, how do you navigate, right? Their number one focus was, how do I move the truck, not looking for what we wanted them to look at. It was the wrong focus. And again, we did find issues. It's very good, but we felt like it could be a lot better. And also there was kind of a safety aspect here where I can tell you it wasn't that much fun following around, vice presidents trying to make sure they didn't walk into the wall. Because again, the product and the virtual and the physical space weren't aligned. So it's a bit disorientating, and it doesn't give you a good feeling that you're not going to bump into something. The second thing is, as you saw in the picture before, typically we have a group of people, people from different areas that we want to show the vehicle to, and then we want them to communicate together. They're sharing knowledge between them when they're looking at the product. So when you have the setup that we see here traditionally, you have one person in VR that's looking at the truck, and then you go back to kind of a similar thing where everybody else is following along or looking at what they're seeing in their headset. Usually we're constricted by time, and so this often means that you have one person that's experiencing it and everybody else is just watching. So again, we felt like even though this was a great step forward, it could be better. And where we came to then was this setup, right? So the first thing was we needed to have a space, a virtual reality space that was big enough that we could fit our total product, right? And in doing that, we would eliminate the need for people to need to worry about how to control and navigate around the truck. They could simply do that by walking. They could walk around the truck and they could look closely at things. The second thing is we wanted to bring that group of people into VR. We want them to be able to experience it for themselves. And ideally, we'd love for them to be able to experience themselves and turn to the person next to them and talk to each other in exactly the same way that we would see when we have our physical builds. And you have this, group of people looking at the product and talking about things in a very natural way, really focused on that product. That's the feeling that we wanted to get, but to be able to enable that in virtual reality. And the third part here is, we are a global company. We're a big company. We have manufacturing facilities in different parts of the country. We have global sites, that cooperate together on developing new products. So the ability to not just be able to communicate with the people in the room, but also be able to communicate that at the same time with people in different locations is really valuable to us. So this is the background. This is the vision that we came to ESI with. This is the development work that we have done together over the last few years. And what we're going to show you next then is a demonstration of how this works today. Okay, well, you join us here in the VR lab that we have in Gothenburg, Sweden. And we're going to take you through a typical virtual review that we would have. So what you see here then is a group of people that represent a cross-functional team, including engineers, manufacturing and service technicians. And one of the keys that we've had, and one of the goals we've had from the very start, has been to make this as simple as possible for the people that are in the virtual review. And you can see here how quick and easy it is once they put the headset on to see the truck and start to walk around and look at the product.
From a
technical point of view, there's just a lot of things going on here. So we have the orchestration aspect, putting the resources for streaming the view to the headsets onto an actual user. We do this by picking out colors. You might have noticed that all the headsets are color coded so that we can reference to user and also to device in a certain way. And then we also need to connect the virtual environment with the real life scenario that we have in this room. And this is what we use the calibration point for that you see marked out on the lower end of the screen, where we ask people to just for a brief moment stand on top of this marker, and we can either use a self-service where people in the headset can book themselves in and calibrate, or we can actually, for let's say less experienced, less proficient users, have a operator do that. And that was the person on the left that you just saw.
Okay, and then here we see several different views. In the top right corner, you'll see in the view from within the VR headset. And what you see here is both the digital truck, but then you also see a layer that's actually showing you the physical surrounding. So it almost looks like a shadow. You can see the surrounding walls and also the people that are in the room around you. And this pass-through, as we call it, has been really important to, build a level of comfort here when you're moving around with multiple people in the scene.
Right, and in this special scenario, we've even allowed people to use the ladder to have a sneak peek into the cab. This is not something that you would normally be comfortable doing in a fully VR environment. So we basically do a kind of mixed view, and that allows people to do this, to feel comfortable, to see each other, and given the calibration, it is also a safe experience.
Here we see one of the real benefits of having, again, a digital truck. Right, we're able to change the view that we have during the session. In this case, we're able to remove the cab so that we can look at some of the components on the chassis and around the engine area.
This also motivates one of the key considerations of the technical setup of the system, because in order to do that, we obviously need the full scale data with no actual parts taken out of it, and also no special preparation for the actual visualization we need. This is key to also reduce the iteration cycles, to give a team really the opportunity to do this on a day-to-day basis if needed. And the source of this data is obviously in product data management, product lifecycle management systems. And one of the key attributes of the system is to really give the teams that work on the data pretty much a direct channel of the data into this environment to help them really look at this as often and as frequent as they want. And of course, that's also one of the motivations why we're using NVIDIA's Cloud XR technology, because the complexity we're talking about here is something that needs dedicated GPUs and can't really run on a standalone headset with limited resources. We also have people that are not actively immersed users, and we need to provide them with a view into the scene as well. We will share some more details on this later in the talk, but it's a really important aspect of the system.
Exactly, yeah. And I mean, because even when you have a number of people walking around in that same space, knowing where they are, seeing where they are, is really important. And what we've found in many of these reviews is that people actually, during the review, the interaction they have with each other when they're talking, they leave their headsets on because they feel so comfortable in the environment. Now they're at the back end of the vehicle, and you can see how important it is that we have this large room that we can contain the full truck in. But again, we've really based this on being as simple as possible for the users to navigate, and we've kept the tools very simple for them. So in addition to being able to walk and navigate around, we have a highlighter tool where we can point to specific parts that everybody can see, and then also a way to mark certain areas that we want to come back to and review at a later time. And then you could start to build up these annotation sets over a number of different reviews and have a way to come back to those.
And that really gives this whole environment also a connection to how a project and a product moves over time. And we can use these annotations to really come back to a situation later and do a detailed analysis. So the data in itself becomes sort of a living entity on the timescale. And going back into one of these situations, we now have a more focused meeting where we have a smaller group looking at one specific detail.
And one of the keys that we found with virtual reality is, again, we're taking this is the same data that we have virtually used in other types of studies. But typically what we found, the feedback is that people have a higher level of confidence in the data when they're seeing it in VR. A couple of studies we had, people had said, their confidence level was, let's say, 60% based on a virtual study. And then when we looked at it in VR with them, that confidence level jumped to maybe around 80%, and to the point at which they were comfortable to sign off on that design without having to do a physical mock-up.
Hello and welcome once again to this GTC Talk 2022. I'd like to pick up where Steve left off before we showed the demonstration with this slide, which actually sums up our challenge in a very, very good and consistent way. We basically picked up this challenge when looking at technology at a point in time where none of the key technologies that we have today, including CloudXR, had been available. Looking at the original requirement, again, the challenge that we picked up was to support 10 plus users in a room of 10 by 10 meters, reviewing a full product with no to minimal interactions. This includes the challenge of simplicity. So Volvo didn't want any senior staff or actual operators to figure out how to use this new technology. I mean, VR headsets can be quite complex if you have to consider all of the environment, including the PC they usually come with. They wanted to avoid any kind of artificial or simulated locomotion or navigation mechanisms because of simplicity, but also because the space is available and it should be possible to walk a product, even if it's as huge as a truck, just natural. They wanted to minimize interactions so that users could basically just onboard themselves or have a person help and assist them if required, but with minimal time effort. So to be able to have a session starting right away was really, really important. They wanted this to be a safe experience, so no cables, please. Avoid anything that would potentially be a danger to participants. And related to that, they also wanted to maintain user comfort. They have been tried backpacks, so basically put the computing power right where it's needed, but that was not an acceptable option. So we had to look at other technology. And if we remind ourselves of the scenario and setup, we actually have the space, but a typical kind of VR space would just fit into maybe a third of the truck. So what we need to extend this to actually the full room and support large-scale product-size interactive spaces, have safe and reliable co-location, and with good participant comfort. It should be mobile, so basically put it up anywhere. Put it up very, very quickly, and also minimize the time taken in lead up. So basically data preparation and obviously also maintenance and IT involvement. So our first challenge was making it work. We had some technical considerations, and with technology developing over time, we chose to rely on inside-out tracking technology because we've seen that these systems, as available in the original Meta Quest, but also recently in the Focus 3, and a bit less so in the original Focus Plus, were very well capable of covering those 10 by 10 meters. We also had picked up that data sensitivity could be a crucial factor, and that we had very, very large requirements with regards to complexity. So basically a typical product, as you've seen today, is at least 100 million triangles, but that does not include all of the variants that Steve was showing that we were able to render in real-time ray tracing. And that has been about 150 million triangles. So there always is room for more complexity. And what you can see from that is that it's pretty much impossible to do this on a just standalone headset using the very capable chipsets that are now in these devices, but that are far from, let's say, capable to render this kind of technology, complexity, on the device itself. We also need interactivity based on rigid and also elastic body real-time physics, and you can imagine this is also a problem on these devices, so we need some more capable iron to do this. And like on the last line on this slide, but one of the most important aspects is we needed to solve the challenge of co-located collaboration in a safe and trustworthy environment. So the process that we've looked at as a design for our first illustrator looked at a environment where we would support a provisioning and producing group that used standard desktop applications to produce data to extract from PDM, PLM systems, and then basically share that with users, but also with setups or environments or rooms that would basically get access to the data. In order to achieve that, what we're proposing is to use what we call the immersive service fabric. So basically a combination of a microservices architecture, access to file store, access to web applications is handled by a central data center location that also can use distributed GPU resources. From consumer perspective, what we put in as devices to support for virtual group reviews is standalone headsets, quite naturally, is an additional screen that we wanted to cast information to give audience participants a kind of virtual window into what's going on. We wanted to support sort of mobile cameras to drive those screens using a tablet mobile augmented reality application. And we also wanted to enable the operator or moderator persona to really drive the session using tablets. Now, this aligns very well with the vision that we've shared for the first time on GTC Europe in 2017, so I'm not going to go into too much detail on this, but we were driving this vision for the past years, and it very well aligns with the challenge that Volvo set to us and also with the technology that is CloudXR. So this enables us to really drive environments such as this through a unified VR data center infrastructure. And that includes supporting devices and environments that are non-local, so basically distributed, like a home office, for example. But on the non-technology aspect, from a process point of view, we already have a design with regards to how we want to support these environments. And a key aspect of that is that we have a continuous backbone of information flowing. So like we saw in the demonstration in Gothenburg, we have data that is provisioned, that is put into a group review, and then there is an additional step that can basically mean that the whole setup will review the information again, given annotations have been created, and the whole process repeats itself over time. So we have a vehicle that is handled by the immersive service fabric that carries the information over time and allows users to enrich the information with their decisions and their findings. Now, from a technical perspective, what's needed for this to work is basically, besides the GPUs, besides the network infrastructure and the services, an app to display and deploy onto the actual standalone headsets. Now, the NVIDIA CloudXR SDK includes a basic Android client application, and this is made to fit Meta devices, or previously known as the Oculus devices, but also HTC headsets and compatible ones by use of the Wave SDK. The existing sample code that comes with the SDK uses the native application infrastructure on Wave. It also uses the native APIs currently on the Meta devices. What we have had to do in order to support pass-through, so basically a mix in between the physical world used by the cameras and the virtual scenario, is to actually scratch build an app that uses OpenXR and uses OpenXR's capability to use pass-through in overlays that can then be rendered into buffers, combining it with the Cloud XR results on the device. So we've built that from scratch, but we're using NVIDIA samples in order to deploy on the Vive headsets. What we've also done is same as pretty much the paradigm that NVIDIA has chosen for the Cloud XR client, sharing a common kind of library that handles all of the underlying methods for transmission of the image and also for distribution of the pose data and the device information in a kind of overarching fashion. We've built our own front end that basically comes on top of the device native kind of aspects of the apps, which is also agnostic and can be used on whatever device. Given it is a part web application, part native application, we can make this compatible to almost any kind of device that currently is or will be coming to the market. On the rendering side, we're basing this on our existing infrastructure. Mainly this is comprised of a back-end rendering SDK that can be flexible. What we support right now is OpenGL Optics, but also Vulkan. On top of this, we have our own rendering framework, which handles all of our rendering for all these applications concerned with XR. And we've made complements to that rendering infrastructure by also employing NVENC for video encoding in real time on the GPU. And the OpenVR and OpenXR interfaces. Currently, we're still building on OpenVR since this is also what Cloud XR uses to communicate at this point in time. And given that this already makes the application compatible with NVIDIA Cloud XR because that interfaces with SteamVR, we wouldn't actually have to add anything else into this, but we also add our own streaming for audio and also video. In order for these capabilities to work, we have added our own streaming component into the software consisting of a video capturer using NVENC technology and also audio video transmission using standard WebRTC technology. The setup itself consists of NVIDIA Cloud XR running immersive headsets. What we support is basically the full range of headsets currently available. In the data center, we can use visualization nodes, basically using from RTX configuration Quadro formerly, and now RTX GPUs. This is scalable if you would like to deploy it that way using RTX servers, and we can also run this on virtualization, so basically vGPU. This is currently based on a Windows deployment and will basically be compatible with any sort of size or flavor. So you can run on bare metal using a workstation, you can run on bare metal using notebooks, but you can also go into a full-on data center. Connectivity-wise, the streaming is based as per headset manufacturers on Wi-Fi 5 or Wi-Fi 6. We are happy with a 1 gigabit connection for any sort of access points and workstations in the mix. With regards to the topic of real-time ray tracing, and we had an example of how this looks and how it can be used in the talk today when Steve was displaying all of his variants on the product. I would like to point out that we have another talk this year from ESI on GTC 2022, which is S41608, driving high-end head-mounted displays using DLSS, optics, and Vulkan in a multi-GPU environment. And this is really interesting if you would like to know more about the way how really high-resolution headsets can be used based on multiple GPUs in the most efficient manner. Also, the past ones of the years we have built up quite a history on these could be interesting since they always base on the newest technology with regards to rendering for XR purposes. Now, one of the challenges in this also is to make it usable. We've heard that the original requirements are quite intense on how easy it has to be to actually book in, but also to take part, and how safe it has to be in this environment. Now, traditionally, headsets come with their own tracking, so every device has its own coordinate system, and we need to synchronize those. You've seen in the beginning of our live demonstration that we have a very simple process for this, and that is basically our solution to the problem. This enables us to measure the space and to keep it in sync across all of these devices. Now, the second challenge basically is, well, how do you actually put users and devices together? How do you really, after fusing sort of the virtual and the real space, how do you orchestrate devices to users? Volvo has come up with a really brilliant solution towards that, and they use color coding on the headsets to make this really straightforward to users. You basically pick a color, and in the system you will also choose the same color, and then that means you're Mr. Red, Mr. Yellow, or Mr. Blue. And this also has been dropped into the actual flow of the meeting, because moderators can actually communicate more efficiently like this, and even audiences have a reference that they can use to identify certain users. Now, the next aspect of the system when booking users into it is matching avatars. We have the color chosen in real life, but how do we actually apply this to users in virtual scenarios? Now, this is basically the step from grabbing a headset, then booking yourself in. The middle part on the slide here is what you see in the headset, but also what an operator or moderator can use to assign you to a certain session. And these sessions are basically bound to rooms, but they could also be bound to users. So you choose where you are, you pick a color, you go. So there's just a single button to click, which is the connect button, and then you're in the system. And an audience can then also pick up who is Mr. Yellow and who relates to this in the room by just looking at the color on the shared audience view. Now, as an evolution of what we've shown in the past years on this technology, we've also looked into engaging remote users and audiences. So as a web application, we supply the establishment service that you've just seen pretty much to any device that runs a browser. And what we've recently added is that we have full audio conferencing as well. And since NVIDIA in CloudXR 3.1 now supports the microphone output as well, we can use the audio conference to basically join in all of the users that are live in the room into one big audio conference. And remote participants using WebRTC on their web browsers can also join in. We will have a demo of this shortly. And it enables us to basically establish communication to users that are at home, that are maybe on a different location, don't have access to the technology, so no headset or no local resources, but can still take part into one of these sessions. And basically, a different form of interacting with these sections is also possible. You can see that on the image above by using a smartphone, because almost all of these devices today come with WebXR capabilities, so they can track themselves, and by again locating the device using the marker as you see here on the floor, you can use it as a virtual camera. So you basically get a view that's live, that's updated from the scene as if you were wearing a headset, but on a 2D kind of screen. So this experience is also based on streaming. It's not based on CloudXR, it's based on a different kind of stream that we base on WebRTC, so that we can also use the audio conference capabilities and just run this on a browser without having to have native support. So this is essentially what it looks like. We have a follow mode that follows a headset. We've recorded this actually while recording the demo that you've seen today. And after the user green lights the microphone use, we can also get live audio.
Hi there, yeah, we're just recording the session for GTC. Nice of you to drop in.
So basically that gives you the voice of the headset user. This was my voice as I was actually using the headset live at that point in time. Now, the third dimension of the challenge that Volvo put to us was to make it scale. So after making it work technologically, after making it usable, they wanted to now also extend this to more locations and to basically bring this to more users. And there's multiple dimensions to that. We are starting in Gothenburg at the key location for Volvo Group Trucks Technology. And our initial deployment was based on a lab, basically. So an isolated environment where the technology was tested. And from there, we moved into production and also into the actual pop-up XR environment. That was the namesake to this talk. And we're now moving to actually build up a system at Volvo in Greensboro, and the team there is working to get this done and up and running. So we'll now look a little bit into how this works from an IT and also from a challenge perspective with regards to bringing this technology into organizations. And it is a really challenging technology to do that with, since the standalone headsets we are using are based on Android as an operating system. It's often something that is not compatible with high security environments, so solutions have to be identified and found. Same for Wi-Fi deployments. A standard enterprise Wi-Fi might not be up to scratch to actually feed a Cloud XR device with the necessary bandwidth and latency requirements. So it needs to be on the most recent technology, and that in turn also has implications to security and deployment considerations. So policies might apply, technology might be new, there is no standard IT shop deployment for all of this, and this had to be overcome. And on the more data perspective, processes need to be set up on how to actually build the data pipeline for this. We have heard that this is a have it every day, have it as fast and as frequent as possible solution. So it needs to be on a level where data can just be used. And this requires interfaces and setups to be connected, for example, into PDM, PLM systems as in use in these environments, so that you get the original data quality. And for example, all of these variants are available. Now, a basic example of how this looked like is the lab example that we started with. So this was just 3 workstations. One of them was running the service infrastructure for this environment. And we had 3 headsets that we could drive using 3 NVIDIA GPUs. And in addition to that, what we were using is a router, which is an off-the-shelf router that is Wi-Fi 6 compatible. In order to make this compatible with an IT conscious and a security conscious IT environment, we actually put this into an isolated network. So you could see that there was a just optional WAN connection on this. But in order to make this more usable, what we're driving is to make this a more centrally deployed environment where a data center would handle all of the resources, where the, let's say, isolated or protected environment for the devices is actually localized, but the parts of the infrastructure that are compatible with any typical enterprise environment, because they're really building on standard technology, standard services like WebRTC, what we can do is we can sort of separate the problem, divide et impera, and have the standard compatible deployment aspects in the corporate network, visible, tested, and security qualified, and have the parts that are currently in a testing or in a pre-certification stage isolated into networks where they can't really break out of this. Why is that possible? Because of streaming. No data needs to be on these devices. For a security conscious environment, that's a big benefit because the data does not leave the data center, it's just pixels. We can encrypt those connections, and we can also tie the rest of this in with existing technology. So we really support an existing workflow and an existing pipeline. Now, as an extract from the services that we use, what is in use currently is standard ports on standard web applications. So nothing that would actually surprise the typical IT environment with unreasonable kind of demands. Sort of combining it all together, this is the deployment architecture that we propose. It is based on a enterprise environment that could use enterprise stacks if available. It can also be deployed on a public environment if enterprises are ready to deploy on a public cloud, this is something that can be done. What we typically see is that in these environments, and certainly goes for Volvo Group trucks technology as well, an on-premise solution is preferred, and this is what we primarily built the system for. So we're using the local enterprise network as a high-speed backbone in order to drive various devices. First and foremost, of course, standalone headsets using the Wi-Fi network connected to that. We've shown the sample as to how to do that, but there could be existing infrastructure using virtual reality headsets that are traditionally wired, and why exclude them? So what we do is we basically tie those in as well. They can be configured to join a room and then basically take part in these sessions as well. User comfort is on a different level, but still we can use existing technology and tie this in with the installation. If there's home office users, remote sites to support, then we typically recommend to base this on existing VPNs, since we don't really transmit a lot of data, as we're not transmitting GPU streams for CloudXR, for example, across these networks due to the security concerns that there might be. A standard internet connection is usually sufficient in order to just display the video stream and audio conference that we offer using establishment. But we can also tie in systems that are powerful enough that users might have at home into our collaborative network. So that means they can actually join the group of CPU and GPU resources that really drive the system. So it would be possible to be a full participant in your home office as well. And this is something that we do and support in our base technology since years. So ISADU as a solution does that, and it is native functionality that we bring in. Here's something that I really wanted to share with you, because you might be wondering, now, we've heard a lot about technology and a lot about how this is put to use, but where's the pop-up XR, right? So this actually is an example of how you could make this mobile, putting all of the resources needed onto a card. And since we have quite low requirements with regards to the kind of infrastructure that we need, it's not a lot of components, they can actually be made to fit onto a mobile environment. So if you don't have the Wi-Fi 6 setup required in your spaces, you can actually bring the virtual environment to the real environment, as opposed to in earlier times bring all of the people into sort of a lab environment to experience the technology. And we believe this is how it should be. Now, if you're interested in this evolution from a technical perspective, and if you would like to know a little bit more about the user experience aspects, here's 2 talks that we had in the past years. One is of 2021, focusing on the user experience, and we go into a little bit more detail there. And then also the initial one that we had to first make CloudXR solutions available as what we call collaborative virtual workspaces. And with that, I'd like to thank you very much. I've also, and with that, I'd like to thank you very much for your attention. And if there are any questions, shoot them into the chat right now, or send an email to either Stephen or me, and we will happily answer your questions. At this point in time, I'd also like to extend another very warm thank you to Stephen for bearing with me on this talk, and also to NVIDIA for hosting us this year again. So thank you very much. Have a great day. Enjoy GTC, and hopefully see you again next year.